Today we're going to look at conditions for parallelograms. There's a lot of different ways you can tell that a quadrilateral is a parallelogram. The first one is by definition. Notice it says if both pair of opposite sides of a quadrilateral are parallel, then it's a parallelogram. So this is a shorthand way of writing it. A quadrilateral with opposite sides parallel implies that it's a parallelogram. It can also be proven if one pair of opposite sides is both parallel and congruent. It has both of those qualities. That keeps it from being a trapezoid. Like if the top and the bottom are just parallel but not congruent, that could still be a trapezoid. But if they're parallel and congruent, then it's got to be a trapezoid. And it doesn't have to be top and bottom, it could be left and right also. So both parallel and congruent. So quadrilateral with two sides that are parallel and congruent. Be careful, it has to be the same two sides. It can't be the top and the bottom are parallel and the left and the right are congruent. Again, that could be a trapezoid. It has to be the same two sides. Both pair of opposite sides congruent. If that's true, it's got to be a parallelogram. That's because if we drew in a diagonal here, we could prove the two triangles congruent, and then the alternate interior angles would be congruent by corresponding parts, and then the lines would be parallel. So a quadrilateral with opposite sides congruent implies it's a parallelogram. I usually write something about both pair of opposite sides congruent so that it's clear. Because if you don't, it sounds like you're just saying maybe one pair of opposite sides are parallel. So if you're having to write that out, I would strongly suggest that you don't write it as I did here, but that you go that it's with both pair opposite sides congruent makes it a parallelogram. Page 2. Again, if both pair of opposite angles are congruent, it has to be a parallelogram. Again, this is both pair of opposite angles are congruent. It's got to be a parallelogram. That turns out has to do with if both pair of opposite angles are congruent. It turns out, we'll look at this more later, but in a quadrilateral, the angles have to add up to 360. If both pair of opposite angles are congruent, these two have got to be supplementary. It's the only way that you're going to have this add up to 360. And if these two are supplementary, the top and the bottom are parallel, then these two are supplementary, the left and the right are parallel, so it makes it a parallelogram. And then the last one is if the diagonals bisect each other in a quadrilateral, it's got to be a parallelogram. It can't be anything else. Again, what we could do is if we know this, we could prove the left and the right triangles congruent, then the alternate interior angles would be congruent, then the left and the right sides would be congruent, and because the alternate interior angles would be congruent, the left and the right sides would be parallel. So now I've got two sides that are both parallel and congruent, so it's got to be a parallelogram. So there's a lot of different ways that you can do this. So, page 3. Let's see, 39. All right, we'll slow down a little bit at this point. I zipped through that, but I think you get the idea. Okay, basically it's the properties of the parallelograms plus the one where the same two sides are parallel and congruent. All the rest of them are just, in a parallelogram, the opposite sides are congruent. So if both pair of opposite sides are congruent, it's a parallelogram, right? That one is the one where it's not one of the properties by itself. It's part of one property and part of another one stuck together. All right, so here we want to show that this is a parallelogram for A is 3 and B is 9. So if A is 3, then the length of KL is going to be 15 times 3 minus 11. So it's 45 minus 11 is 34. And the length of JM is going to be 10 times 3 plus 4, also 34. So that implies that segment KL is congruent to segment JM. And I said B up here. I don't know why I do this sometimes. I changed variables in midstream. Let's make it X so that it matches the variables that are in the problem. So the measure of angle LKM is going to be 5 times 9 plus 6 is 51 degrees. And the measure of angle JMK is going to be 8 times 9 minus 21. Let's see, that's 72 minus 21 is also 51 degrees, which means that angle LKM is congruent to angle JMK. And if those two angles are congruent, then what has to be true? Yeah, what's parallel?
KL and JM.
Yeah, KL's parallel to JM by the alternate interior angles theorem. And now, therefore, since I've got a quadrilateral with two sides congruent and parallel, means that it's got to be a parallelogram.
Wouldn't it be the converse of alternate interior angles?
Oh, absolutely it would. Thank you.
And then you would want us to write what's in parentheses on all our problems.
Yeah.
Okay.
Yeah. When they say show it, they're basically asking you to do something that's kind of like a proof. Anyone have any questions about that? All right, everybody's done writing. Great. So same sort of idea on this one. I did this one in particular because a lot of students do it wrong. They do it partly right, but partly wrong. All right, so the measure of angle Q is going to be 6 times 6.5 plus 7. Let's see, that'll be 36 plus half of 6 is 3, so that's 39 plus 7 is 46 degrees. The measure of angle R will be 15 times 10 minus 16. Let's see, that's 134. So what do we know right now?
They're supplementary.
Yeah, so angle Q and angle R are supplementary. And what does that tell us?
Q are parallel to P.
Is parallel to RS.
Yeah, QP parallel to RS.
Oh, yeah.
So QP is parallel to RS by the converse, as Lexi so rightly pointed out, of the same side interior angles theorem. And then let's find the measure of angle S. That'll be 8 times 6.5 minus 6. 48 plus 4 is 52, minus 6 is 46 degrees. So we know two things at this point. We know that angle Q is congruent to angle S, and we know that angle R and angle S are supplementary. Only one of those is helpful to us at this point. It's that R and S are supplementary, because at this point we know that the left and the right sides are parallel, but we need to show the top and the bottom sides are parallel also. So that means that angle S and angle R are supplementary. So segment QR is parallel to segment PS. Because of the converse of the same side interior angles theorem. And therefore, since both pair of opposite sides are parallel, we know that it's a parallelogram. The mistake that people make on that is that they want to say both pair of opposite angles are congruent. And I'm like, well, how do you know what angle P is? And they'll go, well, it's got to be 134 because the opposite angles have to be congruent. And I'm like, wait a minute, that's circular reasoning. You're saying that because both pair of opposite angles are congruent, it's a parallelogram. And when I ask you why angle P is 134, you say because opposite angles are congruent in a parallelogram. Do you see how that's circular? Right? You've said it both ways. All right, so let's take a look at these and determine whether they must be a parallelogram. Not whether they could be, but whether they must be. Justify your answers. So let's look at this first one. I've got the right and left are parallel and the top and the bottom are congruent. Is that enough? No.
No.
It needs to be the same pair of sides parallel and congruent. Or the same two sides parallel and congruent. All right, what about number 2? Yes, because?
Because the diagonals bisect each other.
Right. If the diagonals bisect each other, it's got to be a parallelogram. All right, what about number 3? No. What's the problem?
Choose the opposite sides.
Right, we need the opposite sides congruent. What about number 4?
Yes.
Yeah. Why?
The opposite angles are congruent.
Yeah, both pair of opposite angles are congruent. imply that it's a parallelogram. All right, last example. If I remember correctly, and I apologize I didn't look at this, I think your book is going to ask you to do this 3 different ways. Since we're short on time, let's see, how much time do we have? This class is over at 39. Oh, yeah, 11:39. We've got the time. Let me show you all 3 ways. Okay? So the fastest and easiest way is show both pair of opposite sides parallel. So the slope of JK is going to be -6 minus -1 over -1 minus -4. So it's -5/3. And then the slope of LM, I'm assuming that they gave these to me in consecutive order, is going to be 5 minus 0 over 4 minus 7 is 5 over -3. So I know that JK is parallel to LM.
Wait, why'd you make LM a line instead of a segment?
Oh, sorry. Habit. It's true, right?
Right, but
All right, then the slope of KL is going to be -1 minus 5 over -4 minus 4 is -6 over -8, which is 3/4. And the slope of JM is -6 minus 0 over -1 minus 7 is also -6 over -8, which is 3/4. So KL is parallel to JM. So we've showed that both pair of opposite sides are parallel. Okay? Another way that you can do this is to show that the diagonals bisect each other. To show that the diagonals bisect each other, what we need to do is show that they have the same midpoint. If they have the same midpoint, then they're cutting each other in half. So the midpoint of segment JL, and again, that's a diagonal because I'm not going consecutively. That's going to be -1 plus 4 over 2 and -6 plus 5 over 2 is 3/2, -1/2. And then the midpoint of segment KM have negative 4 plus 7 over 2 and negative 1 plus 0 over 2 is 3 halves negative 1 half. The third option is going to be everybody's least favorite. I can already tell you. In fact, I can almost guarantee a groan from somebody. Show that both pair of opposite sides are congruent. How do we do that? We use the distance formula. Wasn't quite a groan, but so let's see. The length of JK is going to be the square root of negative 1 minus negative 4 quantity squared plus negative 6 minus negative 1 quantity squared. That'll be the square root of 3 squared plus negative 5 squared. That's 25 and 9, so the square root of 34. You don't need to attempt to simplify these because we're just comparing them. So the opposite side, LM, its length will be the square root of 4 minus 7 squared plus 5 minus 0 squared. That'd be the square root of negative 3 squared plus 5 squared. The numbers are all the same except for the signs, and when we're squaring, that's all going to go away. So this is the square root of 34 also. So that's 2 sides. We've got 2 more to go. Yeah, I know. The length of KL is going to be the square root of negative 4 minus 4 squared plus negative 1 plus 5 squared. It's the square root of negative 8 squared plus 4 squared. Let's see, that's 64 and 16. That's the square root of 80. And then segment JM is our last one. I'm sorry?
That will be negative 1 minus 1 minus 5. Or still.
Sorry, did I do it wrong? Oh, negative 1 minus 5. Thank you. I was thinking it was minus negative 5. My fault. Thank you. That would have been one of those ones where you get to the end and you're like, well, they're not. So this is going to be 6. Oh, so that's 100, because that's 6, 8, 10. A Pythagorean triple. Let's make sure JM ends up being the same way. So negative 1 minus 7 quantity squared plus negative 6 minus 0 quantity squared so that's going to be negative 8 squared plus negative 6 squared. Yeah, that works out. Okay. We made it with 2 minutes to spare.